Good morning, this is Professor Elliott. Today is Friday, January the 27th, 2017. Today in our lesson we will discuss some of the basic characteristics and properties of electricity. Alternating current varies continually with time. This is the type of current that's supplied to all our homes and businesses, so we'll be quite familiar with it. The definition of AC, again, is alternating current, and we know it's AC because for a portion of the cycle, I need a pen, here the waveform is positive, and then for a portion of time the waveform goes negative, and then it would just simply repeat like that. Okay, so AC is technically is any waveform that goes positive and negative in a repetitive fashion. For our purposes, AC, you should envision this type of waveform. It's known as a sinusoidal wave, or we normally just shorten it to sine wave. It's not the only type of AC, but it's the most common type. And for right now, that's all we're going to be dealing with. Okay, the other type of electricity is DC, called direct current. Notice that it's a flat, straight line. If this was your car battery, you would say that the voltage remains constant at 12 volts. It does not vary with time like AC that we just looked at does. See the difference between the two? And there's nothing that says that DC current or voltage can't be negative as well. So this is the picture of a copper atom. We have orbitals or shells, and we have various numbers of electrons in each of those shells, and the number of electrons in each of the shells makes up the different elements that we have here on Earth. And copper is a good choice, first choice for any electrical conductor. We could also use aluminum, it's also quite popular, just for sort of cost and weight reasons, certain applications. Inside computer chips, they typically use gold or silver, but most stuff we're going to be working with is copper. Okay, so in the outer shell, it's called the valence shell. Notice that there's only a single free electron, and in that free electron has a small negative charge. And you may recall that from earlier courses in chemistry and or physics. So, and all good conductors have very few number of electrons. Copper only has one, so it's an excellent conductor in its outer shell. Therefore, there's lots of room for additional electrons to come from an electron source, which is a battery. So a battery, the negative terminal has a lot of billions of electrons. It's a strong negative charge, and it can provide electrons temporarily into its outer shell, okay, which are then passed on to the its adjacent atom. So really inside, I'm sorry it's not a wonderful drawing, but inside a slice of conductor we have billions of atoms all tightly packed. It is a solid, so there's high atom density, and then of course then inside the atoms we have the electrons. So the electrons come from the negative source, so the battery is really just providing many electrons on its negative plate, which will then repel the free electrons in the atoms of the copper atoms, and then which will then move to each of the atoms in turn. So really we could say then that the electrons move in ultimately from the battery into the outer valence shell temporarily. It can only hold one electron in a stable fashion, but then are immediately passed on to the next valence shell and its neighbor atom, and so on and so on and so on, and you get a cascade effect of electrons traveling, and that forms the basis for electric current. Okay, so that's in very simplified form how current works. Okay, so formally, current is defined as the movement of free electrons, and we just looked at that. Current flows from the negative source towards the positive. This is called electron flow. Free electrons, valence shell, traveling from the negative source towards the positive, form an electric current. So current is defined as a movement of free electrons. We can also say that 6.24 times 10 to the 18, which is a very large number, electrons flowing past a fixed point in a circuit in 1 second equals or produce 1 amp of current, and the base unit of current is the ampere. So that many electrons flowing past a fixed point in 1 second equals 1 amperes of current. So if you have twice that many electrons flowing past that point in 1 second, you'd have 2 amps of current. Okay, so we've seen in the last couple of slides that current really travels from the negative terminal to the positive terminal. That's electron flow. This is actually, in fact, okay, how it is. But for a long time, people thought, because they didn't know for sure, that current traveled from the positive plate to the negative plate, and that is known as conventional flow. So in this course, I'm going to seamlessly flip back and forth between the two types. It makes no difference which one you prefer. It really doesn't. So don't let that bother you. So half the textbooks out there show conventional flow and half show electron flow. So you really just have to understand what both terminologies mean. But it really does go, the first one, negative to positive. Okay, voltage. Voltage is defined as electrical pressure, much like a hydraulic pump or a water pump generates so many psi, pounds per square inch of pressure. That's basically what a battery does. And it's sort of the driving force which moves the electrons, which we've seen as the current flow through the circuit. Okay, formally, voltage is called electromotive force, shortened to EMF. We normally just use voltage. The base unit of voltage, unsurprisingly, is just called the volt. And you can also define voltage as potential difference. Okay, so if you had a battery, I like my batteries, and make this 12 volts, and you make this one 24 volts. The 24 volt battery will have twice the pressure, if you will, as the 12 volt battery. Okay, the other property characteristics we want to look at is resistance. Resistance is the opposition to the flow of current, and we're going to do a lesson on Ohm's law shortly and explain this a little more. So we'll see current and resistance are inversely proportional. Conductors, which we've looked at, copper has very low resistance because they have a small number of free electrons. The base unit of resistance is the ohm, and we very commonly simply use the omega symbol for resistance like that. Okay, we're getting to the end of this presentation. So what is an electric circuit? Well, An electric circuit consists of a power source, which is simply a battery. This case, this is just a simple on-off switch. Some sort of control element. Okay, it needs a load, which in this case is simply just a lamp. Okay, and these are the conductors which connect all the various bits together. Okay, so if you were to hold that switch closed using electron flow, the current then would flow down like that from the negative source through the circuit, through the load, back into the positive plate. Okay, so just a recap. So electricity, it's invisible, has no mass, no weight. It's a form of energy. So we're going to be working with it in two primary forms: AC, alternating current; direct current, DC. Copper atom is a very good conductor because it has only one free electron in its outer shell. Current is the movement of free electrons. Voltage is electrical pressure. Resistance is the opposition to current flow. Okay, so I hope you found our time together today beneficial, and we'll see you soon enough again. Thanks for watching.